All right, thank you everybody for joining us today for this webinar on what's new in Solr 6. Before we get started, I just want to mention that Lucene Solar Revolution is going to be in Boston on October 11th to the 14th later on this year. I hope everyone can make it, and so look forward to seeing you there. Just to introduce myself a little bit, I'm Cassandra Targett. I work for Lucidworks as Director of Engineering. I've been a Lucene Solar committer since 2013, and most of my focus in the community is on the Solar Reference Guide. At Lucidworks, I'm primarily involved with our open source teams who focus on Solr, Hadoop, and other open source technologies that we work with. So we're going to talk about Solr 6 today, and I will introduce you to many of the features that are coming soon. Solr 6 really builds on the features in Solr 5, and I'd like to start with a very quick look back at some of the work that's been done in the past year in Solr 5. When I started getting ready for this webinar, I took a look back at Grant's webinar that he did a year ago, just about, on Solr 5. And I noticed one thing that struck me was that the themes that he mentioned as big themes for the Solr 5.0 release were themes that we really carried through the entire 5X releases. Features such as bin Solr and bin post, which make it easy to start up Solr, create a collection, add new documents. They were enhanced with new capabilities and really expanded. More APIs were introduced, and the UI was entirely rewritten in a more modern language to allow for more innovations to be available through the UI in the future. Security is definitely something that's been requested in Solr for a long time. And in Solr 5, a framework for authentication and authorization was introduced. A couple of plugins for Kerberos and basic authentication were added as examples for customized authentication plugins. And then a rule-based system for user authorization was added as another example of how a plugin could be written for other authorization systems. Taking a bit of a deeper dive into looking at Solr 5.4 and 5.5. 5.5 just came out a couple of weeks ago. We see these themes again kind of carry through as we get into the specifics. 5.4 introduced basic authentication. In Solr 5.5, the rule-based authorization was expanded a bit and made more flexible. The APIs were expanded. There's a new config sets API. And the collections API really now has quite a robust list of commands and capabilities to manage a collection. New feature to bin Solr came in 5.5 to manage your Zookeeper configuration files and just use that bin Solr script to be able to download your configs. After you edit them, you can use that bin Solr script to upload them. So it's a nice new addition to that script. And as with every release, there's additional performance optimizations, bug fixes, and lots of other stuff that may be very interesting for you. So let's focus now on Solr 6. There are several new features that we'll talk about today. Parallel SQL is probably the biggest one we'll spend the most time on. Another big feature, though, of Solr 6 will be cross-data center replication. Graph queries are now possible. And a couple things that are still in the works for post 6.0 release, more modern APIs, and some Jetty upgrades and new Jetty functionality that will improve performance quite a bit. So let's start with Parallel SQL, which is a feature that has been added to support using SQL statements to perform some really scalable relational algebra with Solr. So it's really seamlessly combines SQL with Solr. Something that I know some have looked for a long time. And one new wrinkle to it is that it can work with very, very large data sets in a parallel fashion. So, if you can perform complex SQL queries across your Solr Cloud cluster in a way that's very fast and very efficient. So the parallel SQL has two modes. Essentially, there's a MapReduce mode, which really is for high cardinality fields and to perform aggregations and distributed joins data. It actually uses a concept of shuffling, very similar to that concept in MapReduce implementations, which partitions the result set for greater scalability. So a partitioning key is important value there. The other mode is a facets mode, which pushes the aggregations to the search engine layer, and only the aggregates are sent across the network. If you're in a situation where you have a lot of data but low to moderate cardinality, that's actually an option that's quite performant. And we'll talk about both of those in a little more depth coming up. The syntax to use for the SQL statements goes beyond just a simple select or select statements. There's quite an advanced and robust set of syntaxes that are supported, and we'll have a list of that coming up. So one of the things to understand when we talk about the parallel SQL feature is that it really builds on two features that are already available in Solr 5. One is the export request handler, and the other is streaming. The export request handler has been in Solr, I want to say, since 5.1 or 5.2 with the latest. And it actually provides the ability to stream sort an entire result set. This can be used with large result sets to export them out of Solr. Building on that is the streaming API, which has a new class, solrj.io, and it is able to stream tuples, JSON tuples, from Solr out, and adds the ability to perform functions on the data, such as groupings, merges, joins, statistical aggregations, and we'll look at a list of that in a little bit. Streaming expressions are essentially a way of making the streaming API more accessible to non-Java programmers. So what will look like a pretty standard HTTP request, if you know Solr requests, can actually be a streaming expression. This uses the stream handler, and these are essentially functions which either originate the stream or operate on the stream. So let's take a look at a sample streaming expression. This is a very simple one. This is just to do with search. So we take a look and we see it's a pretty standard, or what looks like a pretty standard Solr request. We start out with the expression equals search. So if we've defined that we're doing an expression, we're using the search function. And then between the parentheses are all the parameters of that search, which include the collection, my query string, the fields I want back, and how I want the results sorted. And the response here is going to look a little bit different from the standard Solr response. Essentially, start with a result set and documents, and then it's a stream of tuples representing the document in the sorted order. One thing to note about this is the EOF true at the end, which indicates the end of the stream. And that is how any clients who might be consuming the stream will know that the stream is complete. So the search function, there's just one of several functions that are available for streaming, and we'll get into more of what those are. These functions are designed to work with the entire result sets instead of portions of results. And they do two things. One is they define how the source data is retrieved, known as the stream sources, and what is done to the data and how it's aggregated, which are known as stream decorators. One really nice feature of these functions is that they can be wrapped and added to each other. So we'll take a look at a couple of examples of those. This is an example showing grouping tuples by common field values. So we have the same expression equals, and this time we're using expression named reduce. And within that, it has a stream source of search, right? So this is where I'm going to search Solr to get some records, and my query is asking it to find records where the in-stock field equals true. I want 2 fields back, and then I want to group them by one of the fields in the response. And this is the output of that function. I just used the example docs data, so some of these are a little strange because I just indexed all the files, so they don't necessarily all match. But this basically, we have one group head per group with a list of tuples for each one. So my, client would be able to consume that and do whatever I'd like to do with it to display to users. Okay, so I mentioned there were several available functions. The stream sources, again, originate streams while the stream decorators operate on the stream. So kind of 2 sides of the coin there. There are many of these. Some of these, not all of them, but some of them are available in Solr 5. This broader list is only available in Solr 6. So there's actually in the Solr reference guide, there's a page for Solr 5 today and one for future Solr 6. So you'll be able to see which ones are available, which if you wanted to try to use it in Solr 5. I'll skip going over every one of them, but we'll talk about the stream sources first. Search, as we saw, performs a Solr query. JDBC stream source is a very interesting one. It actually searches a JDBC data source, so a database. And it allows joining data from sources outside Solr. Stored in another database that could then actually be merged with joins or in other ways with Solr results. So it's pretty interesting. The facet source provides aggregations rolled up over buckets. Stats gathers simple aggregations using stats component. And topic uses a publish subscribe messaging service. So there's some very interesting possibilities with that, for sure. Taking a look at the stream decorators, we have some obvious ones. Joins, several types of joins depending on what you need. Merge, group, select, those are pretty obvious. The update allows streaming the results to another Solr collection. And then there's a daemon function that can be used for continuous push or pull streaming. So if there's, if you need continual updates, it can work in either direction. And the parallel function provides it will be used by the parallel SQL feature once we get back to that. And that actually defines worker nodes to shuffle the results across, to the worker nodes for the aggregations. Let's take a look at what one of those looks like. Here's an example of a parallel function which wraps a stream and sends it to n number of worker nodes, however many you define. And so note that we have our expression parallel, and the first item that we define is the collection to use for these worker nodes. So these don't have to actually be the same collection that you're trying to query. You can have a other collection that is set up to just be workers, and that might help performance of any particular one collection. The second collection next to my search expression under that is the collection that I'm going to query. So the other parameters that you want to pay attention to are the workers and the ZK host parameters. because that's actually going to define, how to connect to the workers themselves that are going to do the work for this query. Within that search expression, we have a partition keys parameter, and this helps figure out how the results are going to get split when they're sent back to, how they're going to get partitioned, essentially, to when they get sent back to the workers. So, to split up the work across the cluster. So in this case, I'm going to skip the output, since in this case, really, the more interesting part is the fact that the workers are working, and the results of this particular query. I have a slide coming up of kind of walking through what this might look like architecturally, which we'll go through. So we've covered streaming, which, while a lot of it is included in Solr 5, has not yet probably been explored to much of its full depth by users. And building on top of those features is parallel SQL, and essentially you're able to use SQL to query Solr, and by default those queries are they're translated into streaming expressions and are able to take advantage of the parallel function capabilities we just talked about that it inherits from streaming. It includes, so you can write a simple SQL statement or a complex one, however you want, and that is actually automatically translated into a streaming expression by the SQL handler. And there's quite an advanced SQL syntax that's possible. We'll step through a little bit of that. So these are relatively simple examples overall. There are, I wanted to kind of use existing fields that I had in front of me. So we can, support select distinct, where, obviously, for conditionals. So, and which can include Booleans and ranges, and many other features that what you're seeing on the screen is by no means an exhaustive list. There's a lot of options here. Order by and limit. You can limit your statements and your queries. So limited and unlimited queries are supported, right? So but there are differences in them. So limited queries, can use any stored field to be returned, and an index field can be used in an order by list, right? So if you've put a limit on your query, then you can, you can use any stored index field. However, if you do not put a limit, then these queries require doc value fields. In both cases, either to be ordered or to be returned in the results. Limited queries can also have the score returned, but unlimited queries cannot. Which makes sense a bit. When you have kind of a stream that you're not sure when it's going to end, it's harder to do things like have a relative score added to the results. Group by obviously is supported. Stats and other types of statistical aggregations are easily supported. Count, average. There's a large number of these. And having, which is a bit more of a aggregate function. So we have an example of we want to find where a particular field is true, having an average price higher than 5, ordered by the menu exact field. So here's an example of a relatively simple SQL statement where we ask for only 2 fields to be returned if the in-stock field is true, sorted by the manufacturer name, and limited to the first 5 results. So obviously, since I limited this, I could have asked for score, which I didn't. But No, in this I did not define any workers or any of this type of thing, but I could have with HTTP parameters. And so when I'm using parallel SQL, if I don't define those things by default, it's going to use the collection that I'm querying for the workers. And then the results actually here, look similar to the results we've seen so far with a stream of tuples with an end of file notation at the end. The parallel SQL feature, it does support two aggregation modes, and this is an important part of defining your query, so that you understand where, so that you kind of plan ahead a little bit where your aggregations are going to be performed. In what's called the map-reduced aggregation mode, the tuples are shuffled to the worker nodes where the aggregation occurs. So the results are retrieved from each shard, and the worker nodes actually do the aggregations of merging, sorting. They're sorted by group by fields, but then if there's any additional work that needs to happen to the results before it gets streamed back, that happens in the worker nodes. For high cardinality indexes, this is really great. There's another alternative, however, which is to use the facet aggregation mode, which pushes the computation of some of that aggregation to the JSON facet API. So then only aggregates are sent over the network. So the workers do a little bit less work in this case. And for low to moderate cardinality, then this would work great and return very, very fast. So let's step through a little bit of an architectural kind of picture of what's happening behind the scenes when streaming and parallel SQL are working together using the map-reduced aggregation mode. So the first step is the client sends a query to the SQL handler, which translates the statement to a streaming expression. It also selects the worker nodes, and when the worker nodes get the data back, it will merge the results from the worker nodes. The worker nodes execute the query and streams tuples from the data tables back. So this is the worker nodes is where the aggregations occur. The workers query the shards. Queries one replica in each shard. The replica returns the results to the worker. The worker performs its aggregation, returns the results back to the SQL handler, who will, merges all the results from each of the workers and starts the stream back to the client. And all of this happens very, very fast. Okay. So one neat feature of the parallel SQL is there's a JDBC driver, which can be used to query Solr. It's only used with the SQL handler. There's been recent efforts to test it with some database visualization tools, such as Apache Zeppelin, Squirrel, DB Visualizer, I think are currently supported, and more effort is coming in this area every day. So that's actually a pretty exciting feature, is to be able to use a visualization tool to send Solr an SQL statement and get results back and be able to start visualizing the results in these types of tools. Besides the fact that streaming has so many possibilities, this actually, I believe, takes it to the next level of making Solr a central part, a core piece of your data architecture. There's a few best practices. This is new. There's a lot of development still happening here. I think it's pretty functional the way it is. Most of the development is adding new features, and but I don't think a lot of people have had a chance to use it yet because it's not really released yet. But we do actually already have a couple of best practices. If you're, it's one of which is to use a separate collection for the SQL handler and the worker nodes. In that parallel example that we had a little bit ago, I showed the example of using a different collection. This different collection doesn't need to hold any data. It can exist only to handle the SQL requests, and frees up your other collections that may be indexing data at the same time to not have to deal with the work that's happening here. The aggregation mode will be important for deciding. If you decide that in advance, you might see different types of performance results. And it's usually best to partition on what you're grouping on. So if you want your fields grouped by manufacturer name, then asking, making sure that the partition keys is that same field will make the query occur faster. And one final caveat: in a lot of cases, this is we're using doc value fields only. Export and stream request handlers can only be used on fields that use doc values. Because Parallel SQL uses these capabilities, particularly for unlimited queries, then in most cases it will also require doc value fields too. So that's Parallel SQL. I barely scratched the surface of the functionality, and probably most of my preparation time here was trying to figure out what to cut. So if this is something that's interesting to you, there's definitely a lot more information available about what's possible and how it works. I hoped to make a bit of a general introduction, high level, but there's a lot more to learn there. So there are other features of Solr 2 new coming in Solr 6, one of which is cross data center replication. And this is, being able to replicate one or more Solr cloud clusters in 2 or more data centers. Let's take a look on how it works. It really uses existing transaction logs, and it uses leader-to-leader communication to avoid duplicate updates across data centers. It is active passive, which means that the replicated data center is not meant to be actively being updated by or queried. And it can support sort of asynchronous or synchronous indexing, meaning the updates can happen in batches that you can define, or could be happen in more real-time settings. And it's really designed as a system that has no single point of failure or bottlenecks. Here's a graphic I stole from Yannick, because I think it describes actually how it works really, really nicely. What happens here is the update is received by the shard leader and versioned. It's copied to its replicas, and then it is also sent to the shard leader in whatever other clusters. This does not need to be one cluster at a time. It can, it is one cluster at a time, excuse me. It is sent to the shard leader in the other cluster, but that second cluster could be daisy chained to a third one, for example. So it does not have to be, only one-to-one. And that version that was applied to the to the document actually stays with it. So the version, the document version that gets into the peer cluster is exactly the same as from the original one. And then that forwards the document to its replicas. There's a couple limitations to this because the updates are, I think this will work well for a lot of folks, but because updates are processed from the transaction logs themselves, it's not actually synchronizing the indexes at any point in time. It's, if you start, if you don't start from scratch, the integrity of the updates will be assured. However, if the indexes were not initially in sync, the integrity of the entire index may not, may not be fully in sync. So it's kind of recommended to start from scratch with this. But I imagine if you are absolutely sure, and maybe using some of the backup tools, that you should be absolutely sure that the indexes are fully synchronized before starting, and to be sure. It's possible to work with an index that has a very high rate of updates. You just want to make sure to check that this that this system will work for you with the transaction logs being processed by just to be sure that it's kind of the right solution performance-wise for you. And if it's active passive, again, if you are looking for an active solution, there's some developments that are still ongoing in that area. And in general, this feature is marked as experimental for 6. As we start to use it, I think we'll start to have more information and maybe some changes as we go forward to some of the specifics of how to set it up and how to use it. Okay. So graph queries are something that is important in some cases. Solr will now in Solr 6 support graph queries, which are really about finding interconnected data. This is a local param type of query parser, and it's able to follow nodes to edges, right? So the use cases that we might mention with this are find all tweets mentioning Solr by me or people that I follow. I'm going to have an example of that at the bottom of this slide, to just kind of show the syntax. Other use cases, find all draft blog posts about parallel SQL written by a developer I know. Find 3-star hotels in New York City my friend stayed in last year. There's relationship information that is required and interconnectedness of data in different ways than some traditional queries. Another feature that is not going to be in 6.0 but is going to be coming, I think, in 6.1 is an effort to modernize Solr's APIs. So if you've used more than one of Solr's APIs, you may have noticed that each one of them is slightly different. So if you're doing a query, if you are using the schema API to get the schema, until very recently, you used one type of request and one endpoint, and if you wanted to modify the schema, you had a completely different syntax. And then if you went and used the collections API, you had a completely different structure and syntax. Lucidworks actually wanted to make that a bit more consistent. And we started working on this, and I think it will be a good benefit for Solr overall to make to continue with the ease of use that we started in, or not we, that the community started in way back in prior releases. The goals here are make them consistent. Introduce versioning on the APIs, so as users we always know what we're working with. make endpoint names friendlier, and make them introspectable, the API, so that you can query the API itself and find out what its available properties and commands are. And since often APIs are consumed by machines, we thought JSON output by default will be would be better solution. WT is still supported on these, so if you wanted a different output format, that's totally fine. And again, it's coming very soon. I think we're hoping to be ready to commit it to to the 6x branch in time to be in 6.1. So if we take a look, here's a simple request to return all cores. So in this case, actually, I just wanted to see the cores, and this was a single node Solr, not using Solr Cloud. So I used the core APIs. And it's just a standard products example that standard tech products example. Building on that request actually is just Solr v2 cores. Now I want to look at the schema for tech products. So a couple endpoints farther, I have tech products schema, and I would use this endpoint consistently for all my interactions with the schema for this particular core. This is an example of the introspect. We have, again, we follow the same structure, cores, tech products, schema, and then I add a underscore introspect at the end, and it gives me the spec for that, for this endpoint. So I can see where the documentation is online, the methods that are supported, the commands that are available. So as I said, that's coming soon. So there's a little bit more that we could probably dive very deeply into, but we don't have. There's a few other things I want to cover too. But let's see, similarity is changing. So in Solr 6, BM25 will be the default similarity. And if you're not totally familiar, similarity is the Lucene class that's used for scoring. So in Lucene 6, the default similarity is based on BM25 instead of TF IDF. And it's not too different, but it actually uses, it's modified term frequency a bit to base it more on a probabilistic model, to try to guess what the probabilities are that a person would find a certain document relevant. There are, if you're interested in this sort of thing, there's lots of stuff. This actually BM25 has been around for a long time, and it can, and there's more information that you can find about that. So let's see. Also, there's a backup restore API for Solr Cloud that will become available. As I mentioned before, the UI has been rewritten in Angular and now includes some features to manage your collections. I'll show a screenshot of that in a second. And then coming in, 6.0 will be upgrade to Jetty 9.3, which introduces HTTP2 support, which promises some speed improvements, and reduced network connections, and there's a lot of interesting things that we get with that. However, sort of implementing that in Solr will come in later 6x releases. So Jetty will be updated, but we won't be totally using HTTP2 yet. Okay, here's a screenshot of just a collection overview screen, and you notice that on the left side, there's kind of two pull-down boxes now. Again, it's a core selector, and actually I selected a collection. So this is the collection overview screen, shows me the shards if they're active. And there's also a underneath in the left menu, again, underneath the cloud item, there's a collections item Since I'm using Solr Cloud in this example, I can reload all the cores of a collection at once, delete collections, add collections from here. So this UI, I think right now in 5 is the default, 5.5 is the default. However, it has a note, kind of big red note on it. We're going to take that red note off. All right, so some additional information about upgrading if you do want to move to 6 once it comes out. There's a few things that you should know about changes. You will need to upgrade Java. If you are using Java 7, you'll need to update to Java 8 at least. Right now Java 9 isn't out, so you can only probably really go to Java 8, but when, you won't be able to run Java 7. There's some changes to default behavior that we should be aware of. One is that the default schema factory is now the managed index schema factory. So when you start Solr from scratch, you will no longer see a schema.xml file. You'll see a file named managed schema that is designed to be used with the schema API only. And not modified manually. So that'll be the default behavior. If you want to go to what I think is considered the classic schema index, or the classic schema factory, I forget its exact name. You are able to do that, and then you can you manually edit schema.xml the way we have since the start. Okay, so then there's changes to similarity, as I mentioned. If you do not have similarity defined, the schema similarity factory will be used, and that will default to the BM25. So whenever the field type doesn't declare the similarity or any, there isn't any other defaults, BM25 will be default. There was their current, in Solr 5 and earlier, there's a default similarity factory. That actually has been deprecated and replaced with a class, I think it's called classic similarity factory. I should have written this down. I'm sorry. It is in documentation exactly what the names are. Several deprecations that were introduced in Solr 5 have been removed. The default similarity factory, as I just mentioned, was deprecated, so it will be removed. Some get methods on the schema API have been changed, even before the REST API changes that we just, or not, the API changes we just went through. And range date has been removed, sort of finally. It was deprecated a very long time ago and just kind of skipped on all of our major releases. And then there's some SolrJ changes that if you're using that, you'll want to pay attention to. Some classes have changed and been removed. All right. So when is it coming? The first release candidate could be created this week. I'd expect as soon as there is a release candidate, I'd expect release to happen in the next 2 to 4 weeks. There are, I don't believe there's any remaining blocker issues. I didn't fully look. However, so the release candidate could be happening while I'm speaking. But it's happening very, very soon. There won't be another, we won't need to wait too much longer for all of this. If you're interested in more information, sorry about that. If you're interested in more information, the Solr reference guide is going to be the place to go. First, there's already sections written about parallel SQL, streaming expressions. Cross data center replication has been started. Some of these are still a little rough in format and content in terms of they're being worked on. Now that I'm almost done with the webinar, I'll be able to start focusing back on some of on the ref guide for Solr 6. So expect that stuff to be start moving very quickly in the next couple of weeks. For other stuff, Joel Bernstein made a great presentation at Lucene Revolution last October about parallel SQL. And I think at the same one, I did not watch it, but I'm sure it's great. Eric Erickson made one on streaming, expressions and the streaming API. And those are recorded. I think if you go to this one, Yannick Seeley has a blog where he's got some information about the cross data center replication. And he's got a section on Solr 6, and he gave a presentation last week about Solr 6, actually covered much of the same topics that I have here. And he lays the information out in a slightly different way that might, and I found it quite helpful to learn myself a little bit more about these features. So it's worth, I'm sure it's linked to from his blog, so worth checking that out. Charlotte also gave a presentation about Solr 6, actually last fall, I believe. So some of that information, he's got some great examples in terms of timing. I think that information might be slightly out of date. Okay, so just want to say thank you to everyone for coming. And I want to just thank the folks in the community as they're developing or blogging and presenting about the features they're working on or exciting things. I actually relied very heavily on it. So just want to call out some of those folks, specifically Joel and Dennis, Shal and Yannick, Doug at Open Source Connections, who wrote a really nice, very nice blog post about BM25. It helped me understand a little bit more about what it was. And I think now actually we can take questions. My Twitter handle is @Childerelda, which is a long story. If you come to Lucene Revolution, I'd be happy to tell it to you. And otherwise, I think, we have 10 minutes, I think, still for questions.
Thanks, Cassandra. Yes, we do have some time for questions. We have quite a few questions, so we'll try to get to as many as we can. And again, if you had a question that didn't get answered, or you have a question that you don't think will get answered, still ask it. We'll have someone from Lucidworks reach out to you directly. So the first question that we have for you is, does parallel SQL support joins? If so, are there any improvements or limitations around this?
Yeah, parallel SQL does support joins, and my understanding is that they will be more performant, because they're using the parallelization than current joins are. But there are several types of joins, hash joins, left joins. So there's definitely, absolutely, joins are supported.
Thank you. The next question, is parallel SQL only available in Solr Cloud mode?
Yes, it is. Yes.
Cool. Do the architectures between active and passive data centers have to be identical? Can I have a 3-shard, 3-replica cluster and a 1-shard, 1-replica cluster be an active-passive setup? I can repeat that if you need me to.
No, I got it. That's a wonderful question. I'm actually not entirely sure of the answer. I would guess that they do need to be architecturally the same, but I think let's write that down to get back to the asker.
Sounds good, thank you. The next question, does parallel SQL support near queries similar to the slot function of Solr? Where can we find the list of supported operators?
So the list of supported operators is in the Solr reference guide, and there's a section there of new features to support. And actually, I think I can just go back quickly. The link that's at the top of this list here is the parallel SQL interface, and talks a lot about what is supported. I do not recall seeing near on the list. However, I know that document is being actively worked on, and it perhaps has not been added yet.
And just an update to that, we just got a note from David Smiley. Thanks, David. He said it does support near queries.
Excellent. Great.
Cool. Okay, so the next question. What is the delay in the replication across data centers, excluding network latency?
It's configurable. So you can actually batch your updates and do it asynchronously. So you could say, every 100 documents, but then it would wait, or 100 updates, excuse me, then it would wait for those 100. So the delay could be, quite short, could be a little bit longer.
Thank you. Next question. What index format changes are being made from 5.x to 6? Will this break Solr 4 to Solr 6 index paths?
I expect that it will. I'm not sure the exact specifics. I know there are some changes in default behavior with indexes, but at any rate, even if there are no specifics that break from 4x to 6.0, sort of the support contract kind of goes away as soon as the major version changes. So it may in 6.0 be compatible, but by 6.1 be not. We can try to get back with more specific information about that too. I don't recall anything specifically.
Thank you. The next question is, what is the time frame for active-active?
I don't think we can speculate on the time frame right now. There are some ideas that folks have, I think, but and they're being worked on, but they're not. I'm not sure that it's it's not imminent. I wouldn't want to make a prediction like a specific version. I believe we should expect in the 6x line somewhere, but I wouldn't say 6.1 or anything like that.
Thank you. For production indexing, what is the recommended tool, Solr-J or bin Solr?
For production indexing, I would probably recommend Solr-J. Bin post, is actually quite powerful and easy to use, but you're going to have probably a bit more control with Solr-J. Some of it depends too on the data you're trying to index. If you have, a set of CSV files and you know exactly where they are, and that bin, the simpler solution might be better for you. But if you have more complex scenarios or need more, control, then Solr-J might be the better approach.
Great. Does Parallel SQL support geospatial queries?
As long as they're stock values, I think that it could support some. That's actually a great question. Batting 50% on the questions here.
Okay, so the next question. Can Parallel SQL be a direct replacement to the classic way to query Solr in previous versions?
I think it could. Yeah, I mean, it's designed for very large, parallelized, very large data sets and parallelized, queries. But I don't see a reason why it couldn't be a replacement. However, the results you're going to get are going to be like in this streaming format. The syntax that you're using is probably going to change quite a bit. So if you wanted that, if the response doesn't, if the changes to the response are fine for you, I don't see why it couldn't just replace it if you wanted it to. some of it probably too depends on the complexity of your queries. I'm sure someone's going to mention something that they want to use that's not supported yet, but I have no doubt that the design of it is such that someday it could replace entirely. So backtrack from that. But.
Thank you. The next question is, will issuing a backup command back up the entire collection in Solr 6 or just the individual node?
I believe it'll back up. Another great question. I'm actually not sure. I didn't get a chance to look very deeply into that feature. So we'll write that one down too.
Okay, great. Thank you. So we are just about coming up on time. We do have some questions that we owe follow-ups on and then some that we didn't get to. So we will be sure to have someone reach out to those question askers and make sure they get the answer that they were looking for. Thank you everybody for joining us. We have recorded this webinar, so everybody who registered will receive a link to the recording in the next few days. And again, if you had a question and didn't get it answered, look out for a note from someone on the Lucidworks team. So thank you, Cassandra, and thanks for everyone for joining us. Have a great day.